Now let's talk about systems of equations. So, you guys may know systems of equations with just linear lines and finding where two lines intersect. But what we're going to talk about is when you have one line and some other nonlinear function. So let's work with one line and one parabola, or quadratic. So now let's do some examples. How about y is equal to negative 3x minus 7, and let's say that our next one is y is equal to x squared plus 7x plus 14. So how can we find where these two functions intersect? Well, all we have to do is substitute y for the equation. So what we can do is we can rewrite this equation as negative 3x minus 7 is equal to x squared plus 7x plus 14. This way we can find where their y values are equal. And from this we can find for what x value are their y values equal to each other. So let's figure this out. Well, what we can do is we can add 3x and we can add 7 to both sides. So add 3x and we can add 7 both sides. So we're left with 0 is equal to x squared plus 10x plus 21. And from here, just simple factoring. So we get, this is x plus 3 and x plus 7. So we can find that the x's, or x values, are equal to negative 3 and negative 7. Okay, cool. Well, this is just the x value of where they intersect. All we have to do is plug these x values into the equations to find their y values. And normally you'd use the simpler one. So let's plug negative 3x into negative 3x minus 7. So negative 3x minus 7. And that's equal to 9 minus 7, and that's equal to 2. So our first coordinate is negative 3 and 2. Okay. Now let's find our second one. Let's do negative 7. So we have negative 3 times negative 7 minus 7, and that's equal to 21 minus 7. That's equal to 14. Now that we found our next solution, our next coordinate is equal to negative 7, 14. And that's our solution. Now let's talk about some more systems of equations, and let's work with circles. So let's do a circle and a line. So let's say we have the circle x squared plus y squared is equal to 16. And yes, that's the circle equation. That kind of surprised me too. And this is going to look like a circle centered, its center at the origin, and has a radius of the square root of 16, so radius of 4. And let's say our next is a line that is y is equal to x plus 2. So how can we find where these intersect? Well, we're going to use kind of the same method as last time, and we're going to use substitution. So what we can do here is we can substitute y in this equation for x plus 2. So let's do x squared plus x plus 2 squared is equal to 16. And let's solve. So x squared plus x plus 2 squared that's x squared plus 4x plus 4 is equal to 16. So we get 2x squared plus 4x plus 4 and is equal to 16. Now let's set that equal to 0 so we can subtract 16, and now we're left with 2x squared plus 4x minus 12 is equal to 0. And we can factor 2 out of this and divide by 2. And so we're left with not 2x squared, but x squared plus 2x minus 6 is equal to 0. And so now, because this doesn't factor, we can plug this into the quadratic formula, which is negative b, so negative 2, plus or minus the square root of b squared, so that's 4, minus 4 times a, which is 1, times c, which is negative 6, and divided by 2 times a, which is 1, so just 2. So we can simplify this, so negative 2 plus or minus, that's 4 minus negative 24, or plus 24, so we got the square root of 28, and we divide this by 2, and then what we can do here is we can actually factor a 4 out of 28, so we can write this as 7 times the square root of 7 times 4, and we can pull the 4 out, or the square root of 4 out, so we're left with negative 2 plus or minus 2 times the square root of 7 divided by 2. I can divide by 2 here, so we're left with negative 1 plus or minus the square root of 7. And that is going to be our x value, or at least our x values, okay? So now we just plug this back into our equation, and like I said, normally the simpler one. We can find the first one, okay, so negative 1 minus the square root of 7, and that's equal to about negative 3.65, and then we can just plug this into x plus 2, so we can just add 2 to it, and then we're left with negative 1.65. Okay, so that's our first set of coordinates, and now we can find our second set, which is negative 1 plus the square root of 7, and that gives us about 1.65, and now we can add 2 to that because we can plug that into this equation, and we're left with 3.65. And those are our coordinates where the line intersects with the circle. And of course, for future reference, if you ever get if you're working with the systems of equations and you find that there's no solutions, so for example, if you're doing the quadratic formula and you end up with a negative under the square root, then that means that there is no solution, and that means that there is no intersection point between the functions. The next lesson I was supposed to cover is to solve equations by graphing, but I think it's pretty easy and it doesn't really require me to teach you. It's just turning equations into functions and graphing them, and you can just use Desmos or some other calculator. And you just have to find the points where they intersect, and that will be your solutions. So if you just had the natural log of 3x minus 2 is equal to 3 times 45 to the power of 3 minus 5, you would just turn each side of the equation into their own function and graph them and see where the lines intersect. See, it's pretty easy, but if you feel like you need more practice, go check out Khan Academy. Okay guys, thanks for watching. So today we talked about equations in general, so rational equations, square root equations, systems of equations, and I kind of briefly discussed what it means to solve by graphing. My next video is going to be about trigonometry, which may be scary at first, but you'll get the hang of it. So yeah, again, thanks for watching, and peace.